Yes, Sushil, is the issue is resolved at your end? Okay, in the meantime, I'll just let you know about the important instruction. Hopefully, everybody has gone through it. But till Sushil, just I had a communication with Sushil. He has just got some issue related to the headphone. In the meantime, he will fix it up. Okay, so I hope everybody has got uh, links properly through the Google Classroom. If you are facing any sort of difficulty, you please let me know so that I can fix it up from my side if there are, so we can do that. Okay, so in the meantime, I'll just let you know that by 9:30, 9:30 there is an assessment from the AICT, and you all are requested to attempt that. So I have requested Sushil to end up his session by 9:30 to 9:35. So in that way, so he can finish his lecture by that particular time by 9:30, so that there will be no issues for your examination and that assessment. Okay, so yes, Sushil, is it fixed now? Let me hear. Okay. Okay, as far as Dr. Arun Kumar's request, I'll just share a screen and we'll brief out the schedule that we have prepared for you. Just a minute. Okay, so yeah. So as far as the schedule is concerned, this particular PDF is available onto Google Classroom. So today's session will start as it is expected that we are starting from 8 o'clock, right? Sushil will be delivering on IoT and IoT platforms. Then we'll have a formal inauguration at 10:05 to 11, and Professor S.N. Deshmukh, who is the heading our department, he will be the chairman of this. And one of my research collaborator, Professor Philbert Jono from Malaysia, he is also joining. Uh, Joining. I hope screen is visible to you all. You can respond me into a chat window. Okay. So Professor Philbert Jono is going to be available with us, and he will be delivering a talk onto um connected world, a digital initiative. So that one talk from foreign expert is available to you in this particular session, 10 to 10:05. Then there is a formal inaugural function which is being conducted by AICTE. So that is available. So we will be having our second session at 12 o'clock in the noon. So Kunal Datta is there, and by 3 p.m. we have a third session of the day where Professor Surajit Devnath, Head of Department of Biomedical Technology, Tripura, is going to be available with us. Our second day starts with again 8 o'clock in morning because one freelance engineer, um, uh, Miss Sukanya Mandal, she's also delivering a session. So we'll be having tomorrow session at 8 a.m. So 8 a.m. to 10, the session one is on hardware protocol sensors and actuators. Session two is particularly on to again IoT and wireless application protocols. Session three at 3 o'clock, we will be having on to one senior engineer, actually robotics engineer, Abhishek Rane from Robocard. So he is also going to be with us for Raspberry Pi and Arduino related sensors and actuators work related to that. So this. So day three, we are exclusively dedicating towards developing an industrial IoT, and expert from design tech systems, Mr. Suraj Gawande is also there for with us for two sessions, and third session will be on particularly reprogramming happiness. So that is from 3 to 5. Day 4 will be exclusively dedicated towards IoT and cloud, particularly. So IoT and AI, IoT, cloud and AI applications that we are going to discuss for 2 days. From day 4 and day 5, our sessions begins at 9. So 9 to 11, this one session. Then 12 to 2, there is second session, and from 3 to 5, there is a third session. Right. And your examination of IoT will be on day 4 in between 6 p.m. to 7 p.m. This will be available onto Google Classroom. So you can get that. Day 5 will be again starting from 9 a.m. to 11 a.m. Then for
Hello.
session 1. Yeah. Sushil, your voice is coming good. Okay, let me have 2 minutes more. Then
Yeah,
I
sure.
will hand over the session. Yeah. So session 1 is 9 to 11. 2 is like that. So a dedicated session, day 5 will be dedicated to current technology trends in IoT application. Right. So there are two robotic engineers that are going to discuss their expertise on to current trends in IoT applications on day 5 as well. Okay, so this is already available onto the Google Classroom, so you can go and get that as well. So yeah, Sushil, your voice is proper. I hope you can start now.
Hello.
Yes, Sushil.
Okay, good morning all, and
Good morning. Good morning.
very sorry to have this glitch on my voice. Some technical glitch with my headphone. So I'll start sharing my desktop.
Sushil, can you be a little louder, please?
Okay. Is it okay now?
Yes, fine.
Good, yeah. So, good morning all. Today, my plan is to go over with the introduction to IoT, then walk you through some of the projects that we have done with the private and public sector, and the technology trends, like platforms that are available for IoT development. That is just an introduction, and after that we will have an Q&A session. So if you have any questions, or if you wanted to have any doubts in between, you can raise your hand and we can take up the doubt sessions as well. So let us start with introduction first.
Sushil, can you make?
Hello. Yeah, Pravin sir.
Yeah, please make us slide into full screen mode.
Yeah.
Thank you.
Yeah. Okay. So uh, our idea is to go over IoT, and then if you want to understand any topic, you just have to understand these three, like what, how, and what, why, and how. Right. So that is the agenda, or index for this presentation today, and then we will go over technologies as well. So what is IoT? So in terms of definition, you can find it in various books, publications, and various contents on the internet. But in a layman's term, IoT is everything connected with everything. Okay. So that, what does that mean is, we have any device, we have any uh, uh, machine which is doing some of the jobs. We want that machine to be connected to internet. We want that device to be connected to the internet. We want everything to be connected to a central location, so that we can have a better picture of what exactly is happening uh, I mean near to us or in our premises. And having that kind of an information, you can better manage these all things. Like, I mean, if you have electrical parameters known to you, you can manage your internal electricity of your house. You can manage your ACs. You can manage your other devices that you are using. For example, like, if you know your power factor or your voltage is fluctuating, okay, from electrical parameters, you can switch off your other devices to protect them. Can something is wrong. So, so in that terms, we can actually uh, manage all our devices if we are having information coming from all these machines and devices, or things which we are using in our day-to-day life. So what exactly we are talking about is connecting all mobile phones to internet. That is already done. Okay. Connecting all your ACs to internet, which is underway. we are coming up with smart ACs. We are talking about connecting all your cars, vehicles with your internet. We are talking about connecting all your lightings in your house, all your fans, all your music systems to internet. Okay, that means we are talking about a huge amount of field devices. We are talking about a huge amount of data to be generated, and we are talking about enormous addresses to be generated. Okay, so how? I mean, why we are coming up with this kind of an idea is basically uh, we have this evolution in terms of technologies, in terms of hardware. Okay, so if you know, we have this very low energy of operating devices or sensors that are there in the market today. We have a network of uh, high power and low frequencies are also possible with Zigbee and other RF networks. We also have a very big amount of network addresses that can be addressed individually using IPv6. That means, I mean, 2 to the power 256 is the maximum range of addresses that can be individually configured using IPv6. Then we have this big data, which is which can actually handle a very large amount of data. Then we also have this cloud technologies, wherein I mean we can put all our burden of managing a particular system to cloud vendors, and we can just focus on the technology or the services that we are interested in, and we have access to all of these things today. So and again, I mean 5G is coming up, and I mean it will certainly give you more power in terms of network speed and data that you can utilize over such a high speed network. So that means, like, I mean, we have uh, devices or things that can generate data. We have means of communication to transfer that big data to big systems like cloud infrastructure. And we have software technologies available which can actually analyze that big data and put it into uh, into nice dashboard form or a report form to get the information out of it. Again, I mean, we have this control mechanism which can actually use that input data to actually control the field devices that are present using all these things. So if we have all these technologies, then we can certainly take advantage of connecting all these things. I'll not call it as devices, because I mean we are not just limited to devices in terms of IoT. When we talk about, I mean, connecting information or connecting things, we can also connect information coming from your body parts. Like, I mean, you have one bio variables which can actually read from uh, your your body pressure, your heartbeats, your blood pressure, your other, I mean, medical parameters, and they can also be connected to these systems. Okay, that is a medical IoT or healthcare IoT. So, because I mean we are talking about all everything surrounding us. That is why this term is called as Internet of Things. So, in nutshell, like, I mean, what is IoT is nothing but connecting everything with everything over internet. So, if I mean, to understand further, we can also look into the characteristics of IoT. It starts with things. That is, I mean, for better understanding, we focus ourselves for sensors and devices only. That things is actually creating a lot of information or a lot of data which can be transmitted over communication lines, and we can put our intelligence, sort it out, or to present it in a report format or in dashboard format. Then again, we can utilize that information to take decisions that will be in our automation systems, and it will actually form an ecosystem which will be interconnected between various domains, various devices, and various decision makers, and then we will achieve the connectivity between all these domains. Okay, so this all is actually coming into a context of a particular domain. Like, I mean, suppose we used to have an PLC SCADA automation for many of the things, and for a lot of years now, but which is specific to a particular domain, or which is addressing a particular problem only. Like, I mean, suppose we talk about water automation, it will just talk about distribution lines. Distribution line is an entirely a big application in all, but it will work in a silo, right? I mean, we will have that information generated, and that will be automatically distribution of water or distribution of fluid going along with the lines will be managed in a silo. If we talk about complete water automation, we need to consider WTP, water treatment plants, pumping stations, and distribution lines as an whole, and we connect information coming in from all these things in the context of available water, that is pumping from raw pumping station, right? So that will be a contextual information. If we keep on joining these contexts, like, I mean, pumping station is connected with your irrigation systems, wherein, I mean, they know what how much water is there in your dam or reservoir, and then how much water they can distribute over a period of time. Then we can also also include electricity as a different context, wherein, I mean, if the power supply is power demand is low at a particular time, we can utilize that particular time to operate more pumps. Of course, I mean, your distribution line needs to be capable enough to take up that increased load. But that is an example of a contextual data which can be bringing together and build a complete ecosystem based on the isolated systems that we used to have in the past. So moving to the next slide, we have these features. Of course, I mean, connectivity needs to be there. Okay, connectivity means, like, we have various connectivity modules that are available that can be used to interconnect the devices. Then we have this analytical modules, which is actually using machine learning and AI capabilities to retrieve the information out of data. Then we have this low energy consumption goals. That means, like, I mean, we have if we have a better understanding of what exactly is happening and better manage the resources, and it can turn out to be into an energy saving ecosystem. We have another feature of safety, wherein, I mean, data is safely along and is available on a public or private basis, that is based on a service contract. or an SLA. Then we have sensing and scaling. So sensing is like, I mean, we have devices which is reading the information and passing it on. And we have scaling. That means, I mean, based on the new requirements or new new data that is coming in. Based on the amount of data that is coming, we can actually scale the solution. And it is always dynamic in nature. Like, I mean, based on the real-time situations, the context can change or vary, and it should be smart enough to adjust with the changes that is happening in the ecosystem. So these are the features. So I hope you understand what is IoT with this one. Like, I mean, we know why the terms are I mean uh, terms are there, and then we know what are the characteristics and features. Then to understand it better, the next question is why IoT. Okay, so why IoT is required? Because we are lazy. We want everything to be automatic, and we want it fast, and we tend to forget the things. So that, I mean, human errors is the term that we talk about when we talk about some mishaps or something which is not done properly. Okay, this is the main reason why anything is developed or anything is visualized first and then developed, because we wanted to reduce our work and we wanted to be done it in a proper way, right way. Okay, then what are the advantages of Internet of Things? We can connect anything uh, which is available to anyone at anywhere for any business on any network with any context. Okay. So that means, I mean, we have a we have an control, and we have an monitoring on all our surroundings, and which is available for us at any given time. Is the audio is good now?
Yes, yes.
Okay,
Try to be a little louder.
okay, yeah, I'll do. Okay, so these are the advantages of Internet of Things. Then coming to the how part of it, we have I mean, devices, we have communications, we have data. We need to process it, store it, visualize it. Okay, so how all these things are happening is, like, I mean, these devices are there since very long now. We have electrically operated devices which we see everywhere. We have uh, other devices which are operated from different forms of energy. These devices has been there for long. Okay, what exactly we are talking about is making these devices smart. Means, I mean, making these devices pass on information which they have over a communication channel, so that, I mean, we can retrieve that information, and some algorithm or some analytics can actually work on it to retrieve the information. Okay. So making devices smart means, like, I mean, making these devices I mean, enabling these devices to communicate over a network. Okay, so so because the devices are already there, we need to build up a mechanism which can actually talk with the devices, get the information, and pass it on on a communication channel. Okay, and that communication channel may be a Wi-Fi or Bluetooth or Zigbee or LAN, WAN, whatever it is. Okay, so to achieve this thing, what exactly is happening is, I mean, people are coming up with new protocols, new hardware which is adhering to those protocols, like MQ, MQQT or WebSockets or smart sockets, and putting all this in these peripherals uh, to a device like sensors or actuators or motors. Okay, these are the examples of our devices. Okay, so when the devices are handled with these communication channels, that data is going to be available to uh, available for processing. Okay, which will actually retrieve the information, and then we will have a big storage which with to store this big amount of data, and then we will have visualization applications which will actually use the information and present it in a nice understandable formats of dashboards and reports. Okay. So the hurdle here is, like, I mean, we have all our systems I mean developed in a legacy manner, wherein, I mean, the uh, the devices are already installed and with a huge cost. Okay, so what they're talking about, having a small interface which can actually use your existing devices to make it smart or make it available for the communication. This is how the IoT is visualized. Let's go to the next one. Okay. So coming to the building blocks of IoT, let us start from the down, actually, for to better understand this slide. We have devices like sensors, actuators, which are embedded devices like motors and uh, others. Then these devices needs to be communicating with our systems. So we need a protocol to get the information out of it. So protocols like to convert the protocols and to make it available for the edge computing. Okay. Then we have a connectivity module, wherein, I mean, we have this 2G, 3G, 4G, 5G technologies, then we have wired lines, then NB-IoTs, then we have a wide space spectrum and LoRa. Uh, so that is the connectivity module, and then we have a connectivity platforms or connectivity management platforms, wherein uh, wherein we will have an interface between our applications, ongoing applications, with the information coming from the devices. Once the data is available in the application, we can actually have the device management and application enablement, which will talk about device onboarding. Like, I mean, when we see the demo for AWS, or I'll show you the devices in our next presentation. We need to make sure that we identify each device individually. Like each device needs to be unique in the system. So that is achieved by device onboarding. Then we have a data collection and data storing. Then we need to do the data analytics on the data on it. We have to apply the rules from rule engine, and then we have an API to interface with this data and the devices. And on top of that, we have an customer use cases or the end use cases, which will be specific to a particular context. The data is coming in from a device. We don't have any context associated with that until now. But at the end, on the top of it, we have context associated with that. That is fleet management, healthcare, smart cities, industries, or home security. These are some examples of end use cases. So this is how the data is generated, traveled, and utilized in a particular IoT solution. So coming back to the coming to the technologies, we have a variety of technologies that are available with different vendors, because a lot of fund is going into the IoT development. We have a lot of solutions available in the market. Like 450 plus solutions are there, which are considered as big players. Uh, there are small people who are actually developing their own solutions in silos, and on a particular time they're coming up with with productizing these things. That is also happening because of a lot of investment is getting poured into this particular domain. So majorly, we can categorize it into these 10 categories of technologies. We have platforms, we have standards and ecosystems, we have event stream processing, operating systems, processors, analytics, that is network, low power short range networks, low power wide area networks. Then we have device management and security. These are the technology trends that is happening in the market as of now. So I think with the certain understanding of cloud, most of the things are can be understood, like platform, then analytics, standard ecosystems, device management. These are already available features in any of the cloud providers that we can use today. Device management, then networks and processors. These are field related things which needs to be managed into virtual world. These are the things that needs to be managed into virtual worlds with the modules that are developed into these particular areas. And then event stream processing is something which can be used to manage the alerts and notifications based on some events which is happening. Fail-safe PLCs and all can be example of these things in the field. And similarly, we can have a soft events that is managed with within virtual representation of it. It's like in the industry 4.0, right? We have a particular manufacturing unit, for instance, and to better manage it, we need to better understand it, and to better understand it, we need to better model it. That is the core of the industry 4.0. Everything should be available in a virtual model of it. All your processes, all your machinery, all your resources, all your automation needs to be there in the virtual model of the industry. We manage it virtually first, and then we replicate it into our real world the physical industry. So similarly, I mean, we have this. I mean, technological evolution is also on the same level. We have a particular situation wherein, I mean, we power on some light into the into your house, and the light is lit, or it is. I mean, the light is faulty, and you didn't get it lit. Okay, so in that terms, we actually see that the light is faulty and we need to replace it, which is a situation or an event which we handle into our real world situation by changing the light bulb into it. But in virtual things, we will just provide an alarm saying that that there is a problem with light availability in the room, and you need to look into this particular, because the light is not coming from a particular bulb. So that kind of smart home solutions can be built up with this event stream processing applications. Then we have an operating systems which are actually necessary so that the new smart devices can I mean with the processing power that is available with the small units of the devices that are present in the market today. There is a need for operating system to better manage it. So these are real-time operating systems which are available from various IoT software or solution providers like AWS and Google and all. So we can also utilize that to create our own device which is smart enough and having an bigger software capabilities with having their own operating system into it. So that is all for the introduction part of it. If you have any questions, maybe we can pick up questions for next 2-3 minutes.
The student, those have got some questions, they may raise the hand so that I can unmute them and we can come up with a question answer into this particular part if there are any.
You can also reach me with your feedback on sushil.bedre@gmail.com if you have any questions, or if you need more clarifications on anything.
Yes, I think when we go to the second part, Sushil, maybe they might be much interested into the application. So like we can go through it. Now you can go for your second part of the presentation.
So this is an automation pumping station solution that we presented to Government of Maharashtra. Slideshow mode. So on your screen, what you see is an big pumps that are used to pull the water from rivers or any reservoir and put it into the tanks that we see in our city. These are called as ESRs. So the solution is to manage these pumping stations in a web SCADA or IoT manner. Okay. So this is the architecture basically. What exactly we are saying is we will have an Flowmeters, ultrasonic level transmitters, radar level sensors, which are actually connected to an sensor interface module. So why this sensor interface module is because these sensors are not smart sensors because they have been there for a long time now, and when they have procured or installed, this smart sensors was not there in market, and that was not a requirement at all at that particular time itself. So to get the information from these pre-existing sensors, we have come up with a sensor interface module, which is actually reading information from these field devices and putting it uh, into a smart controller or CPU using a GPRS modem. Okay. So the smart controller with GPRS, actually it is interfaced with the sensor interface module, then energy meter, then flow integration or flow integrator transmitter module, then uh, control relay modules. I put these three things in a separate boxes because they are working on a uh, uh, different technologies, and the communication channel is also different. For energy monitor, most of them are using this RS 485 communication. Sensor interface is normal uh, analog data is coming. Flow integration is again analog data on 4 to 20 channel, but we have to calculate the totalizer of it actually. I mean, flow meters normally give the amount of water uh, going through it on a particular time. We have to sum it out to get the total amount of water transmitted or flown for a particular time. Like, I mean, for a day, how much water is retrieved. Okay. And control relays are actually digital outputs and digital inputs as well in some cases to get the feedback back. Okay. Based on these all information, uh, we take all this information and put it with GPRS connection. We put it on internet cloud to an on an cloud server, maybe an EC2 instance, for example, uh, in AWS setup. So once the information is available on EC2 server or in a database, we can put all this electrical all this information can be put into Elastic Stack to retrieve it with dashboards and reports, which can be visualized on computers or your mobiles, or you can also put that information or alarm through SMS or emails. Okay. So this was the basic architecture of it. Then this is a particular example of a dashboard. This particular pump is off, which this has run for 11 hours and 30 minutes for today, and this pump is on from 3 hours and 15 minutes. Power consumption, current, and voltage of particular pump at this particular time is presented on the screen. Hello?
Yes, Sushil, yes, you're audible. There's no problem.
Okay.
You can continue.
Okay. Yeah. Yeah. So after we have this sensors integration available in the system, which can actually integrate flow meters, then levels, water levels, then water and air pressures. This is in what pumping station automation or WTP, but still we need pressure sensors for air. I'll come to it when we see the see some small animation that I have. Then we have temperature sensors, chlorine sensors, pH of the water, turbidity, and these are the oxygens. These are the parameters of water which needs to be monitored and controlled to make it drinkable. Then we have distribution, water distribution network monitoring, wherein we have different pumps which are actually pumping water from your water sump house to your ESRs, the tanks that you see at various places in the city, right? So we used to there are these particular pumps which are actually putting water into these tanks, so that so we need an Flowmeter to measure what exactly the amount of water which is actually going these tanks. So these are the Flowmeters which are put in the beginning of or near the booster pumps and near the tanks as well, so that we can understand what exactly the water loss that is happening through these lines. And there is the NRW or water loss, non-revenue water. And we have different pumping stations and which are actually putting water into these tanks. So you can see there are pressure transmitters here, pressure transmitter here, and then we also have flow meters, and then energy monitoring system for these pumps. Okay, so this is what we have presented or visualized when we designed this system. So these are the advantages of having this automation for the pumping stations. So we have an product of integrated hardware and software that can be used as a platform for other foreign or third-party devices to be hosted or to be managed. Then we have a web-based interface. We have this communication between devices and web interface is GSM GPRS based, which actually having an encrypted channel which actually serves the security concerns for data transmission. Then we have different levels of graphs and data analysis. There are certain characteristics of the reports that we provide. So this integration system actually talks about energy monitoring, then energy analytics, then sensor monitoring, and work monitoring. So why these all things are necessary? Because in many of cases you see because of certain people's influence, the the work is not actually done as per planned. Okay. Like for an instance, if a pumping station needs to be operated on nightly basis because of the energy charges that are low at the night, because of some political influence or local goons, they come up and they just ask people to start the water because they want it to be available to them at that particular time with vested interest and all. So with this automation and all, we have achieved in one of the Maharashtra site actually, which is an loss making setup. We achieved I mean machinery. We achieved profitable goals of the pumping station in just 6 months of time. These are different reports again. This is what the presentation of things are. I'll some pictures for sensors and all. So this is an actuator basically. I mean, what exactly this thing? Uh, this is electrically operated valve. You can say, like, I mean, we can open or close a valve using actuator. It has got open and close operations and feedbacks for the same. And we also have some actuators also have feedback for torque or fault and limit switch. This is actuator fitted on a particular valve. This is valve basically, and this one is actuator. This is actuator fitting. This is chlorination unit. Talk about chlorine in the water, right? So to disinfect the water, this one is a chlorination unit. Sorry. Second, chlorine pumps. Again, a chlorination unit. This is an chlorine sensor, basically. I mean, we put it into a chlorination chlorine transmitters, and it will sense like what is the amount of chlorine available in water right now. Dashboard. This is Flowmeter being installed on 1200 uh, uh, inches pipe. Flowmeter will tell what exactly the amount of water being passed from this pipe. This is a small flowmeter again. This is HMI, human machine interface, for a SCADA system. You're seeing an particular HMI screen wherein it is showing the water in MBR and water in sump, and we have these pumps. This pump is on and this is off. So basically, I mean, we wanted to move water from this sump to MBR. This is again instrumentation for pH and turbidity. You can see the the pH analysis is done here and turbidity is here, and they will be displayed on a respective displays. Outside of the cabinet on door. Turbidity tank in a flow meter. This is a small one actually. 100 mm. This is a particular pump house. We can see these are 500 HP pumps, which is actually sending water from this particular place to all your city. These are level transmitters. The pump. I have a small animation showing WT water distribution operations. So I'll show you some of the dashboard slides. One of this got some historic data actually. I'm not sharing the current data. This is the historic data.
Sushil, can you speak little louder?
Hello, is it okay?
Yeah.
Is it okay?
Yeah, yes,
Okay.
yes.
Okay. So you can see the dashboard here. We have an headworks wherein the raw water is being picked up. It shows the totalizer values and the current flow. Then the pH and turbidity of that particular raw water is coming up. This raw water is going into a flash mixer and calculator. This is actually a bridge which is moving, and this is alum solution which is mixed with the raw water so that the impurities will be drawn down. Then once the water is settled within the calculator, it will come to the water beds. You can see water beds here, and these beds has got different actuators fitted with them, so that the pure water can go here, and once the bed is dirty, it can be washed as well automatically. They have some blowers associated with these beds, and using these actuators, then wash water tank, the water, and blowers, we can actually do the washing of these beds or cleaning of these beds automatically without any manual intervention. Once the water is cleaned, it will go into clear water. We again get the chlorine, pH, and turbidity information of the water, and then we start different pumps to pass on this water to different parts of the city. This is NRW, or non-revenue water. So what is that? That means is like, we take X amount of water from raw pumping station, and we clean it out. We pass it to the distribution lines, and give it to end users or customers or consumers. And based on the distribution or the amount of water being sent to the consumers, we charge them as well. So at the end of a month, if we uh, take this, for instance, maybe this amount is retrieved from raw water, and this amount is billed, we have 31.5% of a loss in the water, which is non non-billed or non revenue is not generated for that. You can see different amount for different months. This particular thing will add the accountability for the amount of resources that we are claiming, and the amount of resources that we are actually using, and the wastage in between. The amount of water wastage or theft in a particular month. That was the thing I wanted to share, the ability of it. If you have any questions, maybe we can take up 2 minutes for the questions.
Yes, if anyone is having a question, please raise the hand so that I can unmute them.
We have one more presentation left, that is a small one actually, to introduce with the IoT platforms.
Yes, I think we can go with the presentation now.
So before starting the presentation, I would technical on how exactly this thing is achieved. Okay, so from field devices, actually, we have a big SCADA system available at this particular site with Siemens PLCs and all. But I mean, as you know, these PLCs and devices and all, everything is not IoT capable devices. Okay, so these are the first IoT implementation in the state, wherein I mean we converted all this information uh, into uh, into web sockets and put that information on cloud. And from there, I mean, we are actually achieving this thing. So because I mean the devices are not IoT enabled devices, or even PLC is not IoT enabled devices. What exactly we did was we take we read the information from PLC, put it in an cloud database using web sockets and all. So actually we use this EC2 uh, from Amazon AWS as an our static server uh, with the static IP associated with that. We put all that information through normal sockets from uh, I mean, SCADA computer to this EC2 instance. And from there, I mean, we have an .NET program which will actually read the information coming on a socket over TCP and put it into the cloud DB, which is these all things. Coming to platforms. So again, I mean, to understand anything, that we'll start with what, why, and how. So we are, I mean, interested into the IoT platforms right now, but I mean there are many other things as well. But if we talk about IoT platforms, it's an cloud enabled services. Basically, I mean most of them are providing it as an extension to their cloud services, IoT uh, IoT services. Along with that, there are other players in market which are actually utilizing this cloud as an pass, and then that is platform as a service, and then building IoT suite over that. Okay, so to talk about IoT platforms, we uh, we have to consider the points of having an cloud support as well as having an device supports, and then cloud I mean having cloud support, having device support, and having having a capability to store this big heap of information or data, uh, and capability to uh, read very report using that particular data. So again, checking it out. So we have to look into the characteristics as well. So it should be prospective, it should be simple, it should be open. Just three characteristics. So to be a prospective, we need some standards. They are communication standards into it. Then we have a development paradigms. So so communication standards means, like, I mean, because we are talking about Internet of Things, it should be supporting all internet standards, right? Like HTTP, IPv6, and low power devices, and then in a development paradigm where it should be supporting asynchronous communication, because uh, I mean, we are talking about remote area locations wherein these devices are placed, wherein I mean we may or may not have communication channels easily available. So asynchronous communication should be supported. Then lead bindings and functional programming is some development paradigms that are there with the IoT platforms, and it should be simple. Simple means like we are talking about connecting everything to everything and which is available to everyone. So it needs to be simple enough so that anyone can plug in their system, whether it is small or big or medium, and it should be. You should not have. You should not require all the expertise in all the areas and all the domains to utilize the platform. Okay, in terms of development, deployment, and operations. Then it should be open for the community and for the licensing. So these are the characteristics of the platform. Then we have some simple we have these three famous platforms actually available: AWS, Google, and Ka. So in terms of pricing, we have very good pricing in for Ka. Actually, this Ka is a pure IoT platform. We don't have web support or cloud support on Ka. So it actually uses AWS or Google for in their background uh, to store the information or to get the platform capabilities. Okay, so so infrastructure layer is not available with Ka. They use this either AWS or Google. But I am just putting it into the slide to understand what how the platforms are built from different perspectives, and how pricings are, and how that is required to take a decision on technology and platform choices whenever you are starting up a new project on IoT. You have to choose on what exactly your needs are, what is your drivers, what are your non-functional requirements, and based on that one you have to choose for the technology and platforms. Okay, so this is one of the slide that or the study that we have done to understand the uh, the capabilities and to take a decision on what exactly you have to choose in one of our project. Then in if you remember in last presentation, I had shown you all the things wherein we have this we have used AWS as AC2 only. It's just an virtual computer with a static IP. Okay, we can also have a static IP in our local premises, and we can achieve the same thing with that. So what exactly is driving us to have an IoT platform apart from a bulky pocket with heap of money? No, right? So we need scalability, we need simplicity, we need openness, and we need extendability. Because we are focusing on connecting our devices and taking advantage of the information that is being generated. We need it to be scalable, simple, open, and extendable, so that we can actually focus on our devices and information they are generating, not on the uh, infrastructure part of it. So that is the reason uh, we need. Sorry about that, my son was there. Okay, so that is the main reason we need this IoT platforms, and they are there for us. Okay. So what exactly platform? What exactly the platform is, and what services they are providing. Okay. So this is very good representation of an uh, platform or layers that are there with the cloud providers and all, or IoT providers, we can say. So we have this infrastructure as a service, platform as a service, and software as a service. Okay. So what exactly that means is, like, I mean, suppose I wanted to have an uh, capability of sending and receiving emails, for instance. Okay. So to send and receive email, I certainly need a device that is computer or mobile. Okay. Need a mail server, and I need email addresses. So for mail server, uh, I certainly need a computer which is capable of uh, communicating over an internet. Then I need uh, this mail server setup onto that, and after that I will create mail IDs and distribute it along with my users. Okay. So the infrastructure that is needed, like, I mean, the computer, uh, hardware, network, and everything, that is infrastructure as a service. Okay. Then to develop an application, I need few more things on my computer, like, I mean, to develop an or to deploy an mail server. I need few more things that is coming in a category of PaaS, platform as a services. So platform will be used by developers. Okay. So uh, with the with game developers or enterprise developers, we need this platform to be available to them so that they can develop the software for their particular customers. Okay. So you can see the role also mentioned here. Like, we have all the tasks that is done by an IT administrator come under infrastructure as a service. All the task or work that is done by software engineers or developers will come under PaaS, platform as a service, and end users, like, I mean, sending and receiving the email. That is done by that is come under the category of SaaS, that is software as a service. So we have our IoT solutions for all these layers. We have AWS, Google, or Ka, or few others, like Things, and some from Salesforce and everyone. They provide they, I mean, they target their customer on these particular these different layers, and they come up with solutions for for these particular layers. Uh, this Understanding these layers is important because, I mean, we need to take a decision to choose a particular platform based on our requirement, our need, and that need will you can understand that need if you understand uh, these layers of the platforms or the services that are available. Then there are different platforms available, like Google Cloud, uh, IoT, which is based on Google Cloud, then Cisco IoT Cloud Connect. This is particularly designed for mobile connectivity and mobile operations. Then Salesforce. This is particularly for CRM applications, that is customer relationship management applications. Then IRI Voracity. This is all-in-one data management. This is SaaS model, actually. IRI. Then Particle. Particle is a true IoT platform for a layman. I mean, you not to know anything about that. You can actually use Particle and develop your applications. Then IBM Watson IoT. You might be knowing IBM Watson. It's an AI platform from IBM. The IoT extension for it is called Watson IoT. Basically, I mean, you can directly integrate your IoT devices with Watson Intelligence with Watson IoT. Then Amazon AWS, Microsoft Azure IoT Hub, and Oracle IoT. All these three things are, I mean, cloud platforms, which is giving the extension of IoT, enable the devices communication, and put this analytical modules over that particular data, so that we can have uh, the IoT solution ready without worrying much about platform capabilities and communication hurdles with the devices. So wrong animation on this one. So if we talk about Google IoT platform, we have these six major things that are available with that are available with Google platform. That is IoT Core, which is actually for any cloud platform, we need this IoT Core uh, to interface the devices to get the information, collect the data from a particular device and put it on cloud. Then Cloud Pub Sub is an uh, data, uh, data message routing application, which can be, which can be used to reroute the data to a particular different modules to further process it. Then we have BigQuery, that is for data analytics. Then AI platform for machine learning capabilities. Then Google Data Studio for dashboards and reports. Then we have this Google Maps platform for visualizing the location of the devices. This is a unique feature with Google. No other, out of the box, no other platforms provide this map support actually. For a comparison purpose, we will also look into AWS. IoT Core, again, same for connecting devices to the cloud. Then FreeRTOS. This is a unique feature of AWS. Like, they are providing an operating system altogether for microcontrollers. This is a Linux-based one, but they have their own flavor of it. Then one-click IoT. This is to trigger the Lambda functions from data that is coming from IoT devices. This is kind of a scaling of the information or data. So if you know, like, scaling means like, for instance, I have a pressure transmitter which is capable of interfacing on 4 to 20 channel. Okay, what does that mean is it will, the range of that uh, that pressure transmitter is maybe 1 bar. That means 0 to 10 bar, 0 to 10. Okay, and that is transmitted on 4 to 20 line. That means the the, uh, the current of milliampere, 4 milliampere to 20 milliampere will be used to represent this 0 to 10 values. Okay, so when we receive these signals on our in our PLC, we have to scale that, right? If I'm getting a signal of 4 milliamperes, that means 0 in terms of bar. Okay, and if I'm getting 20, then it is 10 bar. Okay, so to scale that value, we have to write down scaling mechanism into PLC. Similarly, if you want to achieve the same thing on incoming data, you can use IoT one-click with lambda functions, so that the data can be scaled according to the requirement. Then we have IoT analytics, that is for data visualization. Then IoT device defender for device security, same as what we have antivirus for computers. IoT device management for device management, like renaming a device, then uh, uh, changing the communication mechanism or communication protocols and all. That can be done into device management. Then IoT events. it can monitor events and trigger the reactions or the control signals for SCADA operations. Yes, all the things that we are talking till now was monitoring. These IoT events is actually a control module of it. IoT green graph. This is a particular IDE for device code generation. IoT site-wise for process automation. Process automation is like, you have all these devices in place. You have all the sensors in place. Now you have a particular situation on that you have to start a certain process. Like for instance, if your water level is rising into your water beds, for instance, it reaches to 80%. We have to start the wash cycle. Wash cycle is in process. So situation is 80% of the water in the bed, and then process is a wash cycle to clean up the water beds. So this kind of processes can be automated IoT site-wise. And IoT things graph. So so this can be actually used to connect the build devices with web services. Like as we know, in a cloud platform, web services is an uh, independent work will be done from a particular web service. So this is, if we want to have that kind of a setup wherein your devices are managed from different web services, so we can use IoT things graph, connect the existing configured devices with existing web services. Any questions in this?
No, Sushil, there's no questions right now. There is one student who raised the hands. Let us give her opportunity to speak. And yeah, Rasika, you can unmute and you can ask question. Sushil, let's take some of the question and so that we can end up this. Yeah.
Okay. Yeah, I had planned to have this demo as well on these all things, but I think we are already out of time, and the technology things are already taken care in the next sessions.
Yeah, Rasika, if you have a question, please come.
Yes, sir.
Forward.
Yes.
Yeah.
Good morning, Sushil sir. I have a small question. Like, what is the basic skill set required to work in the field of IoT?
Okay, so basically, if you see IoT as a domain, there are different level of jobs that are available into IoT sector. Right? You have an operations jobs wherein you have to manage all these devices, field devices, and all. We have services jobs wherein instrumentation knowledge is required. But as a software professional, if you consider IoT as an domain of interest, you will need this cloud cloud knowledge. You will need some of the device instrumentation knowledge. You need to understand this some of the protocols that is web sockets and MQTT. And based on that one, you can actually start up building your applications. So when I started with the knowledge of this socket programming only. I used to take interface the hardware and then pass on that information from socket. So what is the basic of any IoT? Okay, and the more sophisticated tools are available today, which certainly you will learn throughout the course of these sessions. But the basic understanding that you need is just socket programming and device interface.
Okay. Thank you, sir.
Okay, thank you, Rasika. Anyone else has a question? Okay. So we are at the end of this particular session. From the team of the FDP, I would like to thank Sushil for his nice presentation and the demonstration that he has given to us. Actually, that demonstration has opened up some of the opportunities to the participants about the scale of the application which you can build up onto this particular framework. No doubt, like you need to go with details about like how we can program. So very soon we are going to get this particular information. In the second session only, you will get an idea about working with different sensors and how you can build up with the home automation system and agriculture automation that is there. So Dr. Kunal will help. Kunal will show that details with you. He will share that details with you. Okay. So Sushil, thank you very much for being here and giving your insights to the participant. I know that this is little early, but since you are working into the industry, and I personally feel that this particular time is most convenient for the industry professional to get started with. Thank you very much for sharing your views. I would request all the participants to please look at the link of inaugural function which is being posted into your Google Classroom, and that is the only way for getting all those links. In inaugural function, you are going to listen Professor Philbert from University of Malaysia. So I'm expecting all of you be there for an inaugural function. So Sushil, with this particular note, Sushil, I would like to thank you once again. One participant request was there that mm, about presentation. So the presentation will also be available to you into the classroom. So I request Sushil to please share the presentation, a PDF file of it to me so that I can make it available to the participants. So thank you very much, students. So we'll stop here for this particular session. Okay, thank you very much. So we'll end up this meeting now. Yeah.
Thank you.
Yes, thank you very much. Thank you, Sushil.